Hello guys, in this video we'll be discussing about the backtracking in artificial intelligence. So what is backtracking? In the previous video I have explained that backtracking is a recursive algorithm which will be incrementing with the solution. So that is what is backtracking. So in backtracking we'll be able to solve why it is, because backtracking, for example, if you went on distributing 5 rupees to 5 rupees to each and everyone, so at last if you got 3 rupees, you will be seeing that for which for which person I falsely given more than 2 rupees or more than 3 rupees, more than 2 rupees. So this is what it is. So we'll be checking for each and every person in this scenario. This was a scenario. For example, you have 100 rupees, so you are going on distributing, it's a coins of 100 rupees. You are going on distributing randomly 5 rupees, so it is a collection of 1 rupee, 2 rupees, so on. So you are continuously distributing to 100 people. So what will happen? In some of the case you might give more than 7 rupees or more than 5 rupees, that is like 6 rupees, you can give 6 rupees or 7 rupees. But how much you have to distribute? We have to distribute only rupees, the only 5 rupees. So at last, after distributing, you have with the, you have only 2 rupees and you have to give only to the one person, right? But how much you have to give to the that one particular person? We have to give 5 rupees, but you have only 2 rupees. So now we have to check each and every person whether you have given any extra money or not. So in case you have finally one extra money, we have to get back to the last note and we have to dispute to the single one. So this is how backtracking works. So that is one of the examples. So let me write it technically. So backtracking. So backtracking is an algorithm technique for solving problems recursively. So it's a recursive process, because after knowing that the last person didn't have enough money, so we went on with the checking the other persons whether if the money is wrongly given or not. So after the given, we came to the back to the person and we have disputed it. So that's why it is called recursively, by trying to build a solution incrementally. So we have to increment each and everything. For example, you have disputed to one person, second person, third person. So after, we have to move on, going on incrementing to distribute the money. So in incrementally one piece at a time, removing the solutions that fail to satisfy the constraints of the problem at any point of time. Point of time. So this is what the definition of backtracking is. So it's an algorithm technique for solving problems recursively by trying to build a solution incrementally. So we have to increment for each and every person, right? And for each and every person we have to distribute 5 rupees. So we are going on incrementing at piece one piece at a time, so one by one, by removing the solution that fails to satisfy the constraints. So what is the satisfy? We have to give 5 rupees to each and every one. So in case if you give the more than extra money, or if the student is not of our school or our college, what will happen? We should not provide them the money. So that are the something constants. So that type of nodes will be removed. For example, in a group of roses, so if there is a one grass, then what will happen? You can remove that graph. That is what it is, grass. So that is what it is. So constraints for the problem at any point of time. So at any point of time, so if there is an error occurred, then we have to recursively back. That is what backtracking is. So there are 3 types of backtrackings. First one, backtracking. So backtracking is classified into 3 types. I will only explain the definitions. Don't go much deep into that. So first one is the decision problem. So second one is optimization problem, and the last one is enumeration problem. Enumeration problem. So what is decision problem? Decision problem is nothing that in this backtracking searching we'll be finding a feasible solution. What is feasible solution? Feasible solution is the only one solution, that is optimal solution. So in this one we'll be finding we'll be search for a feasible solution in decision problems of backtracking. Whereas coming to the optimal problem of backtracking, here we'll be finding the best solution among all the solutions. So we have to find the optimization solution in backtracking. So we will be search for a. So I will only explain the definitions for this one. So if you want in more depth, I will explain in my data structures video, so you can watch there. So search for a best solution. So what is enumeration process? Enumeration is nothing but we have to continuously generate. We have to search for each and every one. So what will happen? We will be generating more and more feasible solutions. So that is what enumeration problem is that. So we'll find all feasible solutions. So these are the three types of backtracking. So let me take one example and let me make a note. So let's consider this as a starting node. So this is the starting node and you want to enumerate from the starting node. So you will be going to the another node. For next week to find the solution, you will be reaching another node, and you found out that this is a dead node. You found out that this is a dead node. So after finding that this is a dead node is nothing but you will be not having a solution to find. So after it is not a dead node, if it is a dead node, what will happen? You will be coming to the previous node, and if the previous node has the another branch or another solution, you will be traversing to that node. And if this node also is a dead node, what will be having? So this also dead node, you will again traverse back to the node, and you will be saying that this node is entirely dead node, and you will be coming to the starting point itself. So if in case this node has another solution, you will be traversing to the another node. From that one we will be reaching the another node to find a feasible solution. So after that, if you reach this node and if you want to traverse more, when you go on reaching the another node, if you find that there is a dead end. So after when you are going on traversing through the one particular branch, you found that there is a dead node. So what will happen? You will be traversing back again, and you will be trying to find out if there is a feasible solution for that another solution. So you will be moving to the another node, and you will be moving to the another node, and this node is there is no dead end, and this node propagates to another node. So let us take the node. So this node is a dead end node. What will happen if this node is a dead end node? Again we have to traverse back to this node, and we have to find for the another solution, and here we didn't have another solution. What will happen? So there is no solution for us in this particular node. Then what will happen? We will again traverse back to the parent node. So after parent node, we will be finding that there are no feasible solutions for that. So then later we will be again traverse back to the this node parent. So after traverse back to this node parent, we find that there is another feasible solution, and we'll be going to that node. So after that, this node also propagates to the another node, which is a feasible solution for us. So this is how backtracking. So for example, if this also fail, we'll again go back to the parent node and to the start node. So this is how the backtracking works. So if there is any dead end, we'll be again move on going to the previous step to check whether there is any feasible solution or not. If there are no feasible solution, again we'll be moving on to each parents. If there is a feasible solution, we'll be stopping there. So in this case, here is the feasible solution, and the path we have used is this one. The path we have chosen is this one, and the node we have got is known as successor. So CCESSOR, and the nodes which are will be in getting to the successor are called D nodes. Note the nodes which are able to get to the success are called D nodes, and the nodes which gave birth, right, which gave birth to the branch are known as live nodes. Live nodes. Live nodes are nothing but these two. These two are called 9 nodes because this is the only branch which is taking to our successor. That is a success node. It's also called a success node. SUCCSS is also called a success node. And the remaining which didn't take to us the didn't take to the success are known as dead ends. So this is how backtracking works. So you can name it as backtracking process, or backtracking process. So this is how backtracking works. So let me define. There are two types of constraints in backtracking. So types of constraints. So there are two types of constraints. First one is explicit constraint. And the second one is it is implicit constraint, and next one is explicit constraint. What is explicit constraint? Explicit constraint is nothing but we'll be checking how each element in the tuple should be related. For example, if they are, consider this case, so we'll be checking each and every node how they are related. For example, when you start from the start node, and we will be checking that if this node is related to it, or else if this node is not related to it, we'll be not traversing to that, right? So in certain set of certain set of variables, so we'll be trying to traverse each and every variable. Whereas coming to the explicit, we'll be defining that rules that restrict each element in a set. So there are some rules that we coming to the dead node. Is there any traversal to the dead node, right? Dead node, no, right? So that's why if there are no, so the rules of a graphs are in such a way that the dead nodes can't extend to give birth to the another node. So that's why there are some certain rules where we need to obey by the nodes present in the graph. So there are two types of constraints, that is implicit and explicit. What is implicit? Implicit we'll be dealing with. It is how each element in a tuple should be related. Whereas coming to the explicit, what will happen? We have to give rules to the nodes. So rules that restrict each element in a set. So that are the types of constraints. So let me go to the applications of backtracking. So you already know that what are the applications of backtracking. If you have already dealt with the design and analysis of algorithm, you will be able to answer it quickly. There are NQ problem, and second one is sum of subsets. Third one, graph coloring, is also one of the backtracking technique. We have already seen it in previous video, graph coloring. And the fourth one is Hamilton. So there are many more Hamilton. So there are many more applications of backtracking, but majorly we will be discussing all those things. So I will explain this NQ, sum of subgraphs, graph coloring, and Hamilton in my DA subjects, DA playlist, that is design and analysis of algorithms. So this is all about backtracking. So what we have discussed so far, backtracking, it is an algorithm technique where we will be trying to solve the problem recursively, and we'll be building a solution incrementally. So the solution which fails to satisfy the constraints will be removed. So that is what backtracking is. So backtracking is classified into three types: decision problem, optimization problem, and enumeration problems. In decision problem, we will be searching for a feasible solution. In optimization problem, we will be searching for the best solution. In enumeration problem, we will be finding all the feasible solution. So this is the workflow of the backtracking process. If the node fails, we will be going to its parents. If that node also doesn't have any feasible solution, we will be going to the previous state. So this is how the backtracking process works. Then later we have seen the explicit types of constraints. There are two types, that is explicit and implicit and explicit constraints. The implicit is nothing but how each element in the tuple should be related. So there should be some relation, right, between each and every element. So coming to the explicit, we have the rules that restrict each and element from going to the another node. So coming to the application, there are NQ problem, sum of subsets, graph theory, and Hamilton problems are the applications of backtracking. Hope you understood the backtracking. So in case if they give any question on backtracking, just try to explain this process in words, then it will be fine enough, and do one example on this. So I will explain it later, any application, so that will be fine. Thank you for this. Thank you.